Hello, let's take a look at complex numbers and finding the roots of a complex number. So they say that we should find the roots of the equation z cubed is equal to minus 4 plus 4 root 3 of I. So we can see here on the right hand side that what they've given us is in Cartesian form. So my first step will have to be to convert this from Cartesian form into polar form. So I first want to find my r, my modulus. So if I want to find the modulus of z, then I'm going to say the root of, and I'm going to say the root of my real part, so in this case minus 4 squared, plus my imaginary part, 4 root 3 squared. And this is going to give me root of 16 plus 48, and I can simplify this. This will give me root 64, and this will give me 8. So my r, my modulus of this equation is going to be 8. If I want to find the argument, the angle, so let's go and quickly plot this number on our argand diagram. So remember, we have the real part and we have our imaginary part. So my real part minus 4, so I'm going to go negative 4 on my real axis and then plus 4 root 3 on my positive axis. So I notice that my complex number will be in my second quadrant. It's going to be up here. So let's go and take a look at our argument. So if I want to calculate the argument, I notice that I can write it like this. So minus 4, and this will be 4 root 3. So I can say that this is going to be tangent, or I can just immediately write the inverse of tangent of 4 root 3 over negative 4. This will simplify to the inverse of tangent of root 3, my negative root 3, and we can see here that this is going to be negative pi over 3. But of course I now have a negative reference angle, therefore if I want to convert it to a positive reference angle, I can always do, or for tangent I can always go and say this will be plus pi. If it was sine or cosine, we can add or subtract 2 pi, but for tangent we add pi, and therefore our new reference, positive reference angle, will be 2 pi over 3. So now I have my modulus and I have my argument. So let's go back to our initial equation. So if I have something like z cubed, my Cartesian, my complex number cubed, I can use de Moivre's theorem. So let's go and write it out here. So r for my modulus, and then of course I'm going to have cosine theta plus I sine theta, and then I'm going to have my power in this case. From de Moivre's theorem, we know that it is going to be r cubed and then cosine of 3 theta plus I sine of 3 theta. So this is the rule of de Moivre's theorem. So we can see here where we are working towards. Now let's take first for r cubed. So r cubed, we know here in this case was 8. This was my modulus. So I can know that r is going to be 2, because remember 8 is the same as 2 cubed. So r is going to be 2. Then if I want to find my argument, so 3 theta that we have here, and now remember my reference angle was 2 pi over 3. And of course, if I look at the power of z, I can see it's z to the power of 3. So therefore, we can go and we can add 2 pi, because we're working with sine and cosine. If we work with sine and cosine, we can add 2 pi. So the next one will be 8 pi over 3. And then of course, if I add 2 pi again, I will get 14 pi over 3. But I'm not done, because remember it's 3 theta. So therefore my new angle theta is going to be 2 pi over 9, or 8 pi over 9, or 14 pi over 9. So let's go and write it out now for my 3 roots. So of course I can say my first root is going to be 2 cis. So 2 is r in this case, cis of my angle, 2 pi over 9. And then my second root is going to be 2 cis of 8 pi over 9. And then my third root is going to be 2 cis of 14 pi over 9. It depends on the question, what they say, if we should leave it in CIS form or polar form or Cartesian form for my roots, but most likely I can leave my answer like this. So we have found the roots of z cubed is equal to minus 4 plus 4 root 3 of I.